If you want to grow your own tomato but don't want to be tied down to your garden, let me show you how I built this internet and phone control automation system. I assembled the electronics inside the standard outdoor junction box. On the front panel I added the power jack and the status LED that blink once per second to show that the controller is running. The relay controlling the valve are connected to GPIO pins 14 and 27. A 3.3 volts voltage regulator supplied the power needed to drive the relay. For components without mounting hole, I used the hot glue to secure them in the place. As you probably noticed by now, I used the Lego base plate as a chassis. Next I am connecting the cable from the relay to the valve actuator. I am also connecting the sensor that monitor the water level in the barrel. Following the rule that if looks good it works good, let's tidy up the wiring a bit. The main power supply delivers around 16 volts provided by 4 lithium-ion cells. This voltage is required to trigger the solenoid of the valves. To check the water level, I initially tried an infrared sensor, but it turned out to be highly unstable, so I opted for a flat switching sensor that relies on the reed relay. Here is an overview of the whole system before installing it out in the field. Now let's feed the lead with the sensor onto the water barrel. Next I'll connect the supply hose and the automation unit. Main water coming from the tap is controlled by this valve which fill up the barrel. The drip irrigation system is turned on by this second valve. Everything can be monitored and controlled over the internet using this dashboard running on the phone or computer. I am really happy with this automation. I hope the tomato will be too. Now let's take a closer look at the entire hardware and software ecosystem. The control dashboard can be accessed through web browser using a local IP. The core hub connecting your phone to the irrigation controller is a home server built on a mini PC running Proxmox. For messaging and communication, MQTT is deployed, while Node-RED handles the user interface and overall logic on the server. Here is a brief look at the software stack deployed on both the server and the ESP32 controller that operate the greenhouse irrigation. On the server side, the user interface is built visually using drag and drop nodes. I've shared the GitHub repository containing the source code for the flashing the ESP32 along with the JSON file for the Node-RED dashboard interface. If you've made it this far, it means you are genuinely interested in this project and I love to hear you too in the comments. Don't hesitate to ask if anything is unclear. I'll get back to you as soon as possible. Have a great day and I'll see you next time.